Hello learners! Magandang araw! Welcome to TV Eskwela. I am Teacher Ian Grace Badang Lagumbay of Pantukan National High School, Pantukan North District. And I will be with you as you learn an interesting lesson in mathematics for grade 9. It has been said that mathematics may not teach us to add love or subtract hate, but it gives us hope that every problem has a solution. So cheer up and be ready as we solve problems involving radicals. Previously, you learned that a radical equation is an equation in which a variable is radicand or inside a radical symbol. You also learned how to solve radical equations by performing operations on radicals, applying the laws of radicals, and simplifying them. Before we move on, try to answer the given questions by applying the concepts you have learned. I will give you time to do so, and we'll find out later how well you deal with them. Your time starts now. Your time is up. Let's check your answers. Very good! You're indeed doing very well with radicals. These are very much important in solving real-life problems involving radicals. There are different ways to solve problems. For now, I'll be presenting to you the problem-solving maps, namely the MBM or Math Breaker Map and the MRM or Multi-Rule Map. Are you excited to know them? That's great! I will be showing examples of problems and solve them using a certain problem-solving map. You may bring out your pen, paper, and self-learning modules while we go through with our discussion. MBM, or the Math Breaker Map, is a problem-solving map that breaks down the problem into smaller steps. Each step is given in a box that contains instruction and space for the specific step. The arrows represent prerequisites. A step with the arrow pointing to it means that all previous steps must be completed first. Just like in this first example. The length of the legs of a right triangle are 3 centimeters and 3 square root of 3 centimeters. Find the length of the hypotenuse. From this problem, the first box will be the representation of the problem. On the space, we will write the step. That is, we will let x be the length of the hypotenuse. After representing the problem, we will take the next step, and that would be to form an equation. Since the given is a right triangle, we can use the Pythagorean theorem. C squared equals a squared plus b squared. Next, we will solve for the unknown. Using the Pythagorean formula, we will substitute x to c and the rest of the given values. Then, we will have x squared equals 3 squared plus the quantity of 3 square root of 3 squared. Simplifying this equation, we have x squared equals 9 plus 27. Adding 9 and 27, we have x squared equals 36. By squaring both sides of the equation, we have square root of x squared equals square root of 36. Therefore, x is equals to 6. Finally, we will write our answer. The length of the hypotenuse is 6 units. So, that is the MBM, or Math Breaker Map. Next is the Multi-Rule Map, or MRM. With this map, the problem is written as the initial point. Then write a previously learned rule in the cloud next to the point box. That rule will be applied to the problem, and write the next step of the problem in the second box. This sequence is repeated until the problem is solved. We will have example number 2 to show you how it goes. The square root of the sum of 2 consecutive integers is 7. Find the 2 integers. The initial point will be the problem itself. On the box beside it will be the rule you learned previously. The first rule would be the representation of the problem. So, in the box, you will write the representation. In this problem, we will let x be the first integer. The integer next to it can be represented by x plus 1. After representing the problem, the next rule would be to form an equation. We will express the problem as an equation using the representation we come up with. The sum of the two consecutive integers is represented by x plus 1. The square root of that sum will be written as square root of x plus 1. Finally, we will equate this expression to 7. Therefore, the equation is square root of x plus 1 equals 7. After forming an equation, we will use the different rules to solve that equation. Combining similar terms leads to square root of 2x plus 1 equals 7. Then, square both sides of the equation. That will be quantity square root of 2x plus 1 squared equals 7 squared. Applying the laws of radicals results to 2x plus 1 equals 49. By addition property of equality, this is 2x equals 48. Using the multiplication property of equality, x equals 24. Therefore, the first integer, x, is 24. And the next integer, x plus 1, is 25. The two consecutive integers are 24 and 25. Did you get it? That's great! This time, you will apply what you have learned from the previous topics on how to solve problems involving radicals. Let us study the following examples and observe the different ways on how they are being solved. Problem number 1. The side of a square measures quantity square root of 5 plus 3 units. Solve for its area. We have to recall that the formula for the area of the square is A is equals to S squared. Next is to substitute the given in the formula. That will be A is equals to quantity square root of 5 plus 3 units squared. Then, expand the product. That is the product of the sum of square root of 5 and 3 units. Applying multiplication of radicals or the FOIL method results to A is equals to quantity square root of 25 plus 3 square root of 5 plus 3 square root of 5 plus 9 square units. By simplifying, this becomes A is equal to quantity 5 plus 6 square root of 5 plus 9 square units. Then, combine like terms. The resulting equation is A is equals to 14 plus 6 square root of 5 square units. Therefore, the area of the square is 14 plus 6 square root of 5 square units. Easy, right? Let's practice more. Problem number 2. In an electrical circuit, the amount of current measured in amperes, or I, the amount of power in watts, or W, and the resistance, or R, in ohms are related by the formula I is equals to square root of W over R. Find the wattage in a system with 20 amperes and 12 ohms. To solve this problem, first, we must understand the problem. Then, identify the given. Based on the problem, I is equal to 20 amperes. R is equal to 12 ohms. What are we trying to solve is the amount of power in watts, or W. The given formula is I is equal to square root of W over R. We will now substitute the given values of I and R. So, 20 equals square root of W over 12. Then, rationalize the denominator by multiplying square root of 3 to both numerator and denominator in the right side of the equation. That is 20 equals quantity square root of W over 12, quantity square root of 3 over square root of 3. By multiplication of radicals, 20 equals the square root of W times 3 all over square root of 36. Get the square root of the denominator, that is 20 equals square root of W times 3 all over 6. By multiplication property of equality, we can multiply both sides of the equation by 6. Therefore, 120 equals square root of 3W. Then, squaring both sides of the equation gives 14,400 equals 3W. By dividing both sides by 3, that is 14,400 all over 3 equals W over 3. This is simplified as W equals 4,800. Therefore, the power in a system with 20 amperes and 12 ohms is 4,800 watts. This is indeed very interesting. Do you agree? Good to hear that. One last problem for today's lesson. Problem number 3. To save a woman from a burning building, the firemen placed a 10-meter ladder against the window. The foot of the ladder was 2 meters from the wall. Approximately, how high is the window? This problem would be easier to solve if we use illustration. So, we will draw a diagram that represents it. The building, the ground, and the ladder placed against the window forms a right triangle. The diagram looks like this. Next, we will determine the theory involved in the figure. The figure formed is a right triangle. So, we will use the Pythagorean theorem. C squared equals A squared plus B squared in solving the problem. In the figure, C is the length of the ladder, 10 meters. A is the distance of the foot of the ladder from the wall of the building, which is 2 meters. And B is the unknown height of the window. Since B is the unknown value, let us express B in terms of C and A in the Pythagorean theorem. That must be B is equal to square root of C squared minus A squared. Now, solve for B with A equals 2 meters and C equals 10 meters. Substitute the given values to the derived formula. B equals square root of C squared minus A squared. So, B equals square root of quantity 10m squared minus quantity 2m squared. Squaring the numbers inside the radical makes B equals square root of 100 meters squared minus 4 meters squared. Perform the indicated operation. Now, B equals square root of 96 meters squared. Factor the radicand to simplify a perfect square factor. That will be B equals square root of 16 times 6 times meter squared. Simplify by getting the square root. So, B equals 4 square root of 6 meters. Therefore, the height of the window is 4 square root of 6 meters. See how easy it is to solve problems involving radicals. We only need to know how to simplify radicals, rationalize the denominator, add, subtract, multiply, and divide radicals, use Pythagorean theorem, and solve radical equation. I guess you are now ready to accomplish the different activities provided in your self-learning modules. Try to check your answers with the key to answers provided. Keep on practicing, then you'll get used to it. And every math problem will seem easy. Best of luck! So, it has been Math Gandang Araw, and you've learned something new. Another day, proves that nothing can stop learning, not even a pandemic. Again, this is Teacher Ian Grace Badang Lagumbay of Pantukan National High School, Pantukan North District, saying, dito sa TV Eskwela, sa pag-aaral, sama-sama! Bye-bye!